Now let's return to the 3 questions we asked at the beginning of this lecture. Hopefully we should have enough physical insight to understand the answers to these questions. The questions are, why can't we cook noodles faster by adding more and more heat to the boiling water? Why is a burn caused by steam more severe than a burn caused with the same mass of liquid? And is evaporation really an effective cooling process? So let's go to the first question. We'll copy it onto the new page. Can't we cook noodles faster by adding more heat to the boiling water? Adding more heat to water at 100 degrees, as we now know, will not cause the temperature of the water to increase, as instead this heat will be used by the system to transform the liquid into a vapour. So the message here is turn down the heat once you reach boiling point. A slow boil is just as effective in transferring heat from the water to your food to cook it, and it saves power. The second question. Why is a burn caused by steam more severe than a burn caused by the same mass of liquid? Well, steam releases a large amount of heat as it condenses on the skin, in addition to the heat released as the liquid water cools via delta T to the same temperature as your body. What this means, if we write down the equations, is the temperature from the steam equals the latent heat of vaporization, which is the mass times the latent heat of vaporization, plus CWm delta T, where the heat released by the water just equals CWm delta T. Remember, the latent heat of vaporization is a large number, so this is a large amount of heat to be released onto the skin, and this will cause more damage to the tissue. Our last question, is evaporation really an effective cooling process? Let's think what evaporation really is. Evaporation is the process of transforming a liquid to a vapour, and of course it involves LV, the latent heat of vaporization, which we remember is a large number. Now this heat has to come from somewhere, and when this is happening on the human body, i.e. when we perspire, this heat is taken from the skin. Now this is great news if you are hot and trying to cool down. The human body can produce approximately 30 grams of sweat in a minute. So if this liquid is evaporating, we can calculate how much heat energy is removed from the skin via this process. The heat equals mass times the latent heat of vaporization. So we can calculate out that to be approximately 68 kilojoules per minute. This is enough to cool the body even during fast exercise. So yes, evaporation is a very effective cooling process.